Hi, everybody, and thank you very much for joining us today on the second last of our talks this year. For me, it's a particular honor to welcome with us today Peter Terbrugge, who, apart from being an excellent cricketer and a committed roundtabler, was also my first boss when I joined the Drakensberg pump storage scheme in Bergville as a young geologist. Peter has over 45 years of experience in mine engineering and mining geotechnics. He completed a BSc honors degree in exploration geology at the University of Witwatersrand and an MSc diploma at Imperial College London University. He's a registered professional natural scientist and fellow of the Geological Society of South Africa, South African Institute of Mining and Metallurgy, South African Institute for Engineering and Environmental Geologists, and a member of the Royal School of Mines. Peter has had a distinguished career at Stephen Robertson Kirsten, and his specializations include engineering geology, geotechnical engineering, slope stability, open pit mining, and site investigation. He has also carried out mine feasibility studies, due diligence, and independent geotechnical review of mining projects, as well as tunneling. Peter, over to you.
Firstly, thanks very much for having me and inviting me to give this talk. I'm going to kick off with this slide. This is an Antonov, as I'm sure all of you can see. And this is at an airport in the northeast corner of Angola at a place called Serimo. We did a job at Kamutwe Diamond Mine for Kamutwe. Really, this little story is what I do want to say, that if anybody thinks that consulting is a bed of roses, this little story will maybe put you off a role in the consulting field. We were there for about 10 days. We slept in tents, and the ablution blocks were just in a container. In the container, there were basins against the one wall, and in the corner next to the last basin, there was a urinal. So if you happen to be brushing your teeth in the last basin or using the last basin, there might have been a bloke having a wee in the urinal next to you. There were showers and toilets against the other wall. Anyway, we were leaving to come home. We had to fly. We were going to fly back to Luanda that day. And the camp manager got us up at about 2:30 in the morning, because it was about a 6-hour drive from the mine to Serimo. Only about 120 kilometers, but the road was a shocker. Anyway, we eventually got there and we started checking in. And about halfway through, it was one of these new Chinese airports, all glass and chrome. And about halfway through the check-in process, a guy appeared and he calls for our attention to tell us that the flight she is cancelled today. This was a Saturday morning. So somebody pipes up and said, well, when's the next one? He says, Tuesday. All of us said to our driver, we're not going back to the mine. We're not going back on that road again and spend a few more days on that bloody mine. But also there was no accommodation in Serimo. You know, I said to the driver, is there no other way we can get back to land? They said, sometimes on a Saturday, the militaire, they fly. So this was a Russian aid aircraft, and these Russian pilots were manning this thing. So he took us around there. There were 4 of us trying to get back, and it cost us $50 each to get onto this plane, with, I might add, the rest of Angola trying to get on. We took off there at about 2:00 on a Saturday afternoon. It was January time, hot as Hades, and it was, in the next slide, you'll see just how uncomfortable the whole thing was. This was the inside of the plane. There were no seats. People just sat on their suitcases or on the floor. There were screaming babies. At the time, I thought, this is the worst decision I've ever made in my life. I could see the Sunday Times headline, consultants die in aircraft accident in northeast Angola. Anyway, we did survive. That's me. That's not beer that I've spilt on my shirt. That's perspiration. And that's the ramp that you can see behind us here, all those little squares. And when we were trying to board this plane, what turned out to be the flight engineer, he came around, I could see him doing a head count, and there were still about 30 of us who needed to get on. You know, he disappeared, and he came back about 10 minutes later with what turned out to be the pilot, these 2 little Russians in their pluckies and their T-shirts and their smoking cigars and dark glasses hanging around their necks. So he did a count and he gave the thumbs up. So I could see we were going to get on. Anyway, the engineer went in and he lowered the ramp, and then we all climbed on, but the plane was so full, we were all standing on the ramp, about 30 of us. He tried the automatic button to lift the ramp, but the ramp wouldn't go up. So he shouted at these soldiers, there were lots of soldiers around, and told them to pick up this bloody ramp, which they did. And we eventually all just tumbled into the plane. And that was us after being in the plane for about 5 minutes. So we eventually got to Luanda, landed and taxied to the military base. And then they said we had to walk to the gate, which I said was not only a couple of 100 meters. Well, a couple of 100 meters turned out to be about 2 kilometers. And we got to the gate, and the guard, he had no key, and he told us we had now to walk to the main terminal, which was about another 2 kilometers on a hot Saturday afternoon. So not the best experience in our lives, but we got home. And then the next week, nice in a hotel, and then on a flight down to South Africa the next day. This was a job that we were doing in Nkamati, which is a lot of soft rock, saprolite, overlying the hard rock basement materials that had with nickel, obviously. We put out a request for proposals from a couple of drilling operators down in the Nelspruit area, and this was one of the replies that we got. And we asked them for a rig that could do some special things. So this was a rig that was sent to do special things. That rig, as it was there, was towed by a bakkie up onto the site and rigged, and it couldn't drill more than 15 meters. That was the end of that program. So I just thought I'd share that picture with you, which I rather like. Before I sort of get into my main presentation, which is mainly a picture of a whole load of open pits, many with failures, but some very good pits as well. But I just thought I'd take you through this terrible failure that we had at Nchanga in Zambia in 2001. In November of 2000, the mine got in touch with us, and it was Anglo operated at that stage. And they asked Oscar, Stefan, and myself to go up and do a risk review in the open pits for them. In fact, the main Nchanga open pit, which this is a picture of, taken in 1980. That's the south wall that you're looking at. It's a syncline with a very flat south wall, about between 30 and 35 degrees. And then it swings around and comes the north limb is almost vertical. In the south wall, there are two very, very weak lithological horizons, the banded sandstone lower and the banded sandstone upper, separated by about a 4-meter unit called the pink quartzite, which is a hard rock unit, but very blocky. And the two banded sandstone units are aquifers. And what you see here, the instability that you see on the ramp, that was an ongoing problem on that south wall. But the mine managed with it, and it was just too expensive to flatten that slope to something that was less than 30 degrees, because the pit was deep. It was at this stage it was about 450 odd meters, something like that. Anyway, we did the risk review. The first thing we asked for at the meeting on the Monday morning, it was like the proverbial 40, not proverbial, it was the 40-man meeting. It was Oscar and I against 40 of them, effectively. But we asked if they had an evacuation procedure. They said they had, and we asked if we could see it, and they sent a young mining engineer off to find it, and we never saw him again, and we never saw the evacuation procedure again either. Anyway, in 2001, April of 2001, they had a very serious failure. That's just a further picture. So that's what that thing looked like in early 1980. And this was March 90. You see that whole ramp system is gone, and you can see the instability at the crest as well. In 2001, I got a call at about 2 o'clock on a Monday morning to tell me about this failure and could we come ASAP. I didn't phone Oscar at 2 o'clock in the morning, but saw him at the office later, and we managed to book flights up to the mine that afternoon. We got there just after lunchtime, I think. What had happened was, this is looking north to the top of the page, where this blue swathe has gone down into the bottom. All the operations were taking place down there. And that, in fact, was at the 255-meter bench. And that was about 350 odd meters below surface at that time. On the Friday afternoon, one of the managers went down to just to the viewpoint where it says 400 meters in red above that little line. There was a viewpoint there, and he was spending some time there just watching what was happening. And he noticed some settlement at the corner of the viewpoint, which he reported to the geotech engineer, who went to have a look. And it was something that never really worried us on that south wall, because the pit was so deep. Any failures were never particularly deep and only sort of raveled slightly down the wall and got about halfway or 3/4 of the way down the wall and never reached the bottom. So it was no big issue. On the Saturday morning, Abel, who's now the geotech engineer for De Beers in Botswana, he went out to have a look again, and there were cracks. They were big cracks. They were tens of meters long and open 100 to 300 millimeters with the steps of the same sort of order of magnitude. Again, nothing to worry about as far as they were concerned at the time. I think with hindsight, it was a wrong decision. They should maybe have evacuated the people from the pit at that stage. On the Sunday morning, he went back again, and the cracks were big. They were hundreds of meters long, and you can see that they covered a strike length of about 400 meters at that stage. He phoned Bruce Murphy, who was the chief geotech engineer at the time. Bruce was living in Kitwe, and Bruce said to Abel, "You better evacuate the pit." So Abel radioed the control tower and asked them to sound the alarm, which they did. He then had to walk back across the cracks because he couldn't drive over them, picked up the perimeter road, had to drive all the way to the west, and where it says 0 MB, he picked up the ramp that went into the pit, so driving down to the west, and then he picked up the ramp going to the east. And as he was driving down towards the bottom of the pit on that east section of the ramp, this failure happened. And it was 5 million tons of material, which rushed down to the bottom of the pit, and the whole thing was over in less than 5 minutes. Abel was halfway down the ramp, and thank goodness that he wasn't down at the bottom by that stage, because he would have been taken out as well. The upshot of it was, and what everybody did was exactly what they shouldn't have done. When the alarm sounded, they all went into the bottom of the pit. There were three big shovels working there. P&H were not so big in those days, P&H 2300s. And they were electric shovels, and they're now trying to move these shovels out, as well as the electric drills that were drilling off the next blast, production blast in that area. It came down, and I'll show you a few pictures of the destruction shortly, but 11 people were lost in that accident. We had a vague idea of where the people were. It very quickly changed from a rescue to a recovery operation. There was just no chance that they could have survived that. And the recovery operation consisted of, we had a big 994 front end loader at the bottom, and he would go in, dig away at the toe, he'd reverse back to a safe waiting place, and then he'd dribble the material out of the bucket. Because as I said, we did have an idea of where these people were, but sadly, we only recovered what was left of them. And it took us, the first 8 or 9 were recovered quite quickly, within 10 days. And then we found the remains of the last guy about 6 weeks later. So I will just show you some of the pictures from the destruction of this thing. This was the picture of the slope. That's 5 million tons sitting on the slope, most of it sitting out down the bottom. What Bruce Murphy and I did, they were worried about digging out at the toe and re-initiating movement of the failure down into the bottom of the pit again. Bruce Murphy and I walked around on the failure surface. We put some pegs in, and then we had a surveyor sitting at the crest of the pit, and we were monitoring our pegs on they were installed in a pattern, to see if there was any displacement took place while they were digging at the toe, but nothing happened. So from that point of view, it was a blessing and allowed the guys to continue with the recovery operation. You can see some of the equipment in the bottom there. There's a drill. You can just see a drill mast and a bit of a drill, and there's a bit of the shovel that's lying there, which you'll see better in the next picture. There's the front end loader working away. And then you can see there's some trucks buried in the muck pile as well. And then there are a few shovels. The shovels are also there. There's a P&H, what's left of a P&H 2300, which I don't know how much one of those shovels weighs, but it's probably a couple of 100 tons. It just picked it up and tossed it 30 or 40 meters. That's what it did to a grader that was grading the road down there. That's what it did to a Land Rover. And sadly, there were 2 people inside that Land Rover. I mean, that's what a failure like that does. It is violent, and it causes absolute chaos and havoc. We managed to re-establish the slope. We introduced a load of horizontal wells that were drilled into the slope to pull the water out, because as I mentioned earlier, the banded sandstone upper and lower were both aquifers. In the east end of this pit, there was a high-level sump. The syncline was to the west. So water in that high-level sump fed through both the BSS upper and BSS lower units. So that was a wet slope. Also, in the early days, the Nchanga stream came through where it says 4,400 meters, that number there. The stream came through there and crossed the what was going to be the open pit right through where the failure was. Anyway, they constructed a tunnel from more or less where it says 400 meters. It ran along the south of the pit, it curled around the east end of the pit and joined the old stream bed somewhere around about just a grid line or 2 above where it says 600 meters on the eastern side of the pit. They then, from where it exited, where the tunnel exited it back into the river, they pumped water back from there along the eastern edge and then along the grid line, more or less along the grid line that says 400 meters to the plant, which sat more or less where the 4,400 meter mark is. And that pipe used to leak like a sieve. It was about a 0.5 meter diameter pipe. And it used to, when they were pumping water, the water used to shoot 20, 30 meters up into the air. That area where it says the 400 meters, that was a low-lying dambo, and the water always used to pond there. They had made efforts to actually backfill that area, but it was always a saturated area. So the water was a massive problem. Plus, we think that whatever lining, it was a brick lining to the tunnel, and we think that those bricks, there was a fault that went through there as well, and we think that the fault leaked and water leaked into the slope as well. So it was a water-driven instability. When we got to the office on the Monday morning, we, of course, got out all our correspondence, because when I joined SRK in 1979, Nchanga was my first job that I worked on, and I've worked on it ever since, actually. It's only in the last 2 or 3 years that I haven't been up there. But every last report that we wrote said that we needed to have drainage in that slope to get the water out of those banded sandstone units, but it never happened. Also, the monitoring had fallen away, and no monitoring. There was 2 prisms at the bottom end of the failure, which were not being monitored anymore for whatever the reason was. So apart from the cracks, there was no inkling that this thing was going to go, but the cracks themselves should have said, this is what you've got to watch out for. Right, on to better things. This is a mine in Australia. It's a coal mine. It's on the eastern seaboard, a gold mine. You can see the reddish, pink reddish stuff is saprolite, very soft saprolite, strength of maybe not more than 5 to 10 MPa, if that actually. On the left-hand side of my screen, there's a large lake there. It's probably about, it is 12 kilometers long by about 3 kilometers wide, but it's only about 2 meters deep. And that water, they tried to do some cut-off works to prevent water seeping into the saprolite, but they weren't able to stop it. And I've got a slide a little later. It should come after this one, but you'll see it just now. it resulted in quite a large failure. The rock was a hard rock diorite, and you can see the benches in the hard rock stuff were actually quite good, and only a few instability issues of smallish wedges. Here you can see sort of middle right of the screen of the picture. There's sort of a 2-bench failure there on a wedge. There's the plane on the left-hand side, and then the flatter sliding plane on the right-hand side. And then just above the ramp and where you can see the wide bench, there's some plane failures up there, but they didn't really create too much of a problem in terms of the mining. Most of those things came out with the blast, so it wasn't a problem for operations really. This is a mine in Turkey. It's a gold mine, it's Kisledag, and it was a very good operation. The benches where you see the drill in the middle of the picture, sort of bottom towards the right of the picture, the slopes, they were doing very good blasting. They were doing a pre-split first, then the production blast, then the buffer or the trim blast would go off last. And they mined out the production blast first, so the buffer actually moved into free space. These were very, very good slopes indeed. But what I really wanted to show you was, there's Calgold Nolene. This was long after it closed, and this was when they were already pumping tailings into the bottom here, and that's the water. That slope on the left-hand side is steep. It is, if I recall, I think it was close to 65 degrees, which was almost parallel to the foliation that was in that wall, and it was a banded iron formation, so the foliation was quite strong. Having got down to about this level here, we did start to have some plane failures coming off, because the foliation planes were quite weak, and in some areas they were undercut, and we did end up having to put anchors into the wall below that level. So we designed, I think the anchors were 20 meters long, 5 meter fixed length, and nominal tension only to about 40 odd tons. And the benches were 10 meters, so we spaced the anchors at 10 meters horizontally, and the benches were 10 meter high, and we staggered the subsequent rows. So row went in, the next row was staggered, next row staggered all the way to the bottom, but it got them to the bottom of the pit, no problem. This wall was in harder rock, and the slope was steep enough as well, and it worked fairly well. This is the Anglo mine in Nevada, and there was a fault that ran down the side of the failure. What you see here, these workings in the bottom right are, there's an underground portal here, because they went underground, and there were also 2 portals underneath the failure here. The failure was well managed, and they knew it was coming, and the timing and everything was good. Everybody had been taken out of the underground operation. So other than the failure itself and having to clean up the operation, that was the only drawback, I guess. So it was successfully managed. Unlike this one, which is Nchanga again, this is the north wall of Nchanga. This is on the steep limb of the anticline, of the syncline, I mean. There was a unit in that limb called the Chingola dolomite. It was like a talcum powder with chert boulders embedded in it. And when we drilled it, we actually you couldn't sample that stuff to test it. But it was so weak that it effectively had a cohesion of, if it was 5 degrees, it was a lot, and no cohesion. And this failure was a result of that thing being exposed on that bench over here, this area, this flat here. It was exposed on that bench, and it started as a bit of a toppling failure, and then became this. This was before my time, I'm pleased to add. You can see the 2 trucks in the bottom buried in the muck pile. And then that's another truck and a dozer in there, and there's another dozer in here, which I can't quite see at the moment, but there's a dozer there. And this shovel that you see here, this shovel was operating over here somewhere, and when the failure came, it actually pushed that shovel right up against the face that it had been mining over there. able to recover these trucks and the dozers and rehab them, and they all, within a month, they were all back and working again. When they noticed some cracking at the crest of the slope where this foliage is up here, they did put in some wire extensometers which were connected to flashing red lights if the thing moved. I think if the thing moved in these soft materials, you can move as much as 1.5 to 3 meters without the stuff cracking. So a lot of movement takes place before the cracks develop. Anyway, a spotter had been placed up there because they continued to work through the night on the night shift as well. And the spotter, as soon as the lights started flashing and the siren went off, the spotter had to radio the control tower to radio the operators, and for them to move out of the pit. He was nowhere to be found, and I think they never found him again. They don't think he ended up in the failure, but he disappeared off the face of the earth. This is another place where I spent quite a lot of time. This is Anglo-Sadiola gold mines in Mali, and this is the big Sadiola pit. And then there were 3 or 4 satellite pits. There was FE 1, 2, 3, and 4, which were big round pits, but this was the main pit. And this was a shear zone that they were mining. Why I've included this picture, it also had saprolite at the top, and you can see it on the right-hand side of the screen up here. That's the saprolite, and it was quite thick. It was like 50 or 60 meters. So that's the contact is all the way down here. This was a dolomite, hard rock dolomite, no problem with that. And then here you can see there's the base of the saprolite, and then the main ramp into the pit at that stage came down this west wall was. And what happened here, we had the right slope angle in the saprolite, but because the drilling had been fairly sparse, it was not fully covered, and the mine they thought they'd got into the good rock before they had, and started steepening the slope, and all this raveling started to happen, as you can see here. And if you look at the bottom of the pit, you can see all this real material sitting on this wideish bench here, but all these big boulders reporting to the bottom of the pit. And the shear zone, this is a shear zone, and the shear zone runs right down the middle here. We can see that shovel working, where those drills are drilling there, and the shovel digging here. So this became a bit of a hazard. So all this stuff had to be cleared. And when they did come and drill and blast and mine here, they had to have spotters before any people could go in and work in that area. It was an inconvenience, nothing serious, but it certainly was an inconvenience which did delay production. I'm going back to that coal mine operation now, and this is what happened to that saprolite. That slope was about a 35-degree slope angle. I didn't work on this operation personally, but Oscar and I were doing a geotechnical review board visit for them. And these were some of the pictures that came out of that review board. And we are pretty sure, and when we could actually see the increase in the piezometer readings, because there were piezometers in that wall between the crest of the pit and that shallow lake that I mentioned earlier. And the levels were rising in the saprolites, something like about 10 to 15 meters, and that was sufficient to initiate these failures. And somewhere in my work files, I have pictures that show it started with a bench scale failure, which merged into a double bench, and then another failure a little way along, and then it just started to ravel like this. They were able to mine everything out here and re-establish the pit, and they kept going, and it was a very successful operation at the end of the day. This is something different. About 20 years ago, Anglo came to us in connection to a chrome mine that they were operating in Zimbabwe. And it was an underground operation, and there was an offshoot of the ore that they'd found about 300 or 400 meters away from the main ore body, and asked if they wanted to do an open pit, but the rock was very poor. And this picture I have on the screen now is not what I'm talking about. This is the second one we did, but back to the Zimbabwe one, we couldn't give them slopes anything better than about 32 to 35 degrees, and that was going to take out half of the village, the airstrip, and some granite hills that were in the area. So it was a problem, and we put our thinking caps on and we said to them, we think we can do a vertical pit for you. And they said, okay. So we gave them a proposal, and I don't have any pictures of the Zimbabwe one, but we did a shallow cut, two 10-meter benches, so it went to 20 meters deep. We gave ourselves a platform to work on, and we went vertically from there. Being our first vertical pit, we were quite cautious with the anchoring that we had to put in. And the first part of the vertical cut in this weakish rock, and to give you an idea of the strength, in terms of the rock mass rating, which runs from 0 to 100, 100 being really very good hard rock with very few joints or faults or anything yet. And this stuff, the stuff we were working with here had a rock mass rating, an RMR of somewhere between 25 and 35 in the Zimbabwe thick. So our anchors were long. The top 4 or 5 rows were 40 meters long with about a 6-meter fixed anchor length, which is grouted in, and tension to a nominal tension of about 60 tons and a working tension of about 40 tons. And in that Zim pit, we got down, they wanted to go to 100 meters, and we got down to 95. We managed to get that blow, the chrome, out, or in fact halfway down when the bottom fell out of the chrome market, and they decided to stop the operations at that time. But that was a successful operation. The haulage system we used there was a Blondin type system where you have a pivot on the one side of the pit, and then we built a crane beam around the other side. And if you've seen, I'm sure most of you have seen pictures of great big dams, and when they cast the concrete in those big dams, they use the Blondin to do that. So the pivot is the pivot, obviously, and then the crane beam can run from the one end to the other end, and the cables that connect the pivot to the crane beam, the crane on the crane beam, covers the whole exposure of the open pit. So you could drop your kibbles where you were mining, and you could mine and load straight your kibbles, and then when the kibbles were full, the operator would go and load the kibbles, bring them out and dump them into a truck, and off that went to the plant. So that was a successful operation. Then we came to Koidu. This is in Sierra Leone. This wall that you see here, that was a bench in what had been a small open pit in the area, and the client asked us if there was no ways we could steepen slopes in the pit to recover ore to pay for the operations, and we suggested the vertical pit, and they said, let's go for it. So we designed this pit here, also to go to a depth of 110 meters. On this one, we mined up to the kimberlite granodiorite contact, and the contact, what you see in the picture there is obviously it's wet from seepage, quite a lot of seepage. But in these vertical pits, you do have to protect the walls. You can't afford to have anything coming off those walls because you've got people working at the bottom of this thing. And even a fist-sized boulder coming off, hitting a ledge or another rock and bouncing into the pit can be lethal. So once the wall's exposed, we shotcrete the wall with about 50 to 75 mils of shotcrete. Then we fix mesh, and we used a weld mesh in this case, and then it gets another 75 mils of shotcrete, and it seals the wall, and then nothing can come off. It does crack because the rock mass does move as you get deeper, cracks open, and some of the shotcrete starts to peel away. But we had a system whereby we could send a sort of a man cage over the edge here. And in fact, I think what you see here is that man cage in operation where they are repairing some of the damaged shotcrete. Because blasting, of course, this was hard rock in the kimberlite, and blasting had to take place in here. The Zimbabwe thing also had to be blasted. It wasn't that soft that it could be free dug. The hoisting arrangement here was a headgear. This was the winder house that you see over here, I think, yeah. So the cables came up from the winder up to the top of the headgear to this area, and then had to go through 90 degrees to come down to have our kibbles running up and down here. And the drawback of this was that all mining in the bottom of the vertical picture had to be trammed and loaded into the kibbles underneath the headgear. There just wasn't sufficient space for us to do. We couldn't place the headgear such that we could avoid going through the 90 degrees. There was a ramp there, but there wasn't enough space to get us up the ramp and put the headgear on, and then they would have lost access around the headgear into the pit. So this went along very successfully until we got close to the bottom. We were about 95 meters when there was a blast, and this great big wedge fell out. On the right, you can see the kibble going up or down, and these were the pipes were pumping water out of the pit. And we also had to blow some air into the pit because at the bottom it became quite stale. Just to give you an idea of scale, here's a guy standing here next to the rock, and he's probably about, you could say he's 2 meters tall, probably 1.7. This went with a blast, thank goodness. There was no one in the pit. And I got a call again this happened in the morning, and I got a call in the afternoon and was told to get there the next day, which I did manage to. I just go back to this picture. They had strung a cable from over here somewhere across the pit to an area here, and we could go in one of those little air-driven motors in the kibble, and we could go along the cable and we could go up and down. So just coming back to the thing, shaft sinkers were the miners on the site, and when we spoke about the support system, we said to the client that we needed to have one of our young structural engineers on site supervising the installation. I hope none of you guys listening are shaft sinkers or ex-shaft sinkers, but they said, their words were, we don't need anybody supervising us. This is our job. This is what we do. And in fact, you can see some of the anchors over here. There's one, there's another one, there's another one, there's another one. So there were signs of anchors being installed. But when this kibble swung across the face of the failure area here, there was no sign of any holes in this wall at all. There were no signs of any cables that had been dragged out, and in this wall as well. And our design had covered this wedge that you see here. So there should have been, if the anchors had been installed, there would have been no failure, and they would have got to the bottom of where they were. Anyway, they made sufficient, or generated sufficient revenue from what they were able to, the diamonds they were able to sell, and they were able to start the pit, a full open pit operation. And as we speak now, Koidu is actually developing an underground operation. This was Freeport in Indonesia. This was not a pit slope failure, but this was a tailings dam that sat at the crest of the pit, quite close to the crest, and the dam burst actually. It cracked and burst, and all these tailings, this is tailings you see running into the picture. And sadly, they also lost 11 people in this thing, because this is where the mining operation was. And here you can see these are all the officials' vehicles parked here, come down to see what had happened. So it was another disaster. This mine in Chile, Rajo Sur, I think it was called. What was interesting here was we had done some work on this operation, and we were worried about this area of the pit because this was a big fault on that side of the failure, and there was a structure, medium-sized structure down here, and we said this was a problem. The only access to the bottom of the pit was this thing. This came down here, turn around into the bottom of the pit, and this was another ramp out of the pit. And we said to them, if this thing fails, which we think it's going to do, you will not be able to access the pit, and you will, if you're going to try and move all the stuff out, you're going to have to declare force majeure. They said force majeure will never happen to them. Well, it did happen to them, and in fact, at the end of the day, they actually did close this mine. On the force majeure story, and I don't have a picture of it, Batu Hijau, also in Indonesia, that Oscar and I did a review on. The guy that was an American who was running the geotechnics on that pit, and what his modus operandi was, he dug a bench, he mined a bench, and they were big benches. They were 15 meters high, and the face angle was 75 degrees, the bench face. And then once that bench had been mined, he sort of examined the area, no cracks. He paced 5 meters off, and then started the next bench. So he went. And as you can imagine, very quickly, a 15-meter bench with a 5-meter berm width is going to be a very steep bench. And very, very soon the cracks started to develop. Then what he did, he stepped out 10 meters instead of his 5 meters. And that was his design modus operandi. That visit that Oscar and I had, we were trying to sell them the design with risk philosophy. We had a week in Perth with a young Australian team who are really not interested in designing with risk whatsoever. True Aussies, I think, with respect to yourself, Neil, sitting in Melbourne, I think it is. But we spent the week talking to them about it, giving them presentations, and then we went up to the mine, and we had another week there. We never met the GM or the manager mining, or a geotechnical engineer in charge of not the guy that I'm telling you about, because he was just hopeless. On the Friday of the second week, there had been a youngster from Golders there in Vancouver who was installing piezometers, and he was, on that particular day, he was putting his piezometer cables across a ramp. And at Batu Hijau, it was a massive operation. It had 2,600 BME, 2,600 BE shovels, and the big 400-ton trucks. And at about 11 o'clock that morning, Jamie came up to the office to get some more water because it was hot as hell there and very humid. And we spoke to him about the operation, and Oscar in particular said, "Are you sure you're safe?" And he said, "Absolutely." He had flagmen. They had those big bollards, the plastic cones up, and half of the ramp had been sealed off. They'd finished that half, and he's working on I'm not sure if it was the outside half or the inside half. And he said, no problem. He was happy enough. Back he went down in the pit, and about an hour later, the siren went, and there was a lot of running around, scurrying past our office and people shouting and what have you. And eventually, we managed to get some guy to come in and said there'd been an accident in the pit. And Oscar said to me, he said, "It's Jamie." And it was Jamie. He'd been in one of his little trenches across the Hall Road, and the bloody truck had ridden right over him. Because, in those big 400-ton trucks, there's an exclusion zone where the driver can't see of up to 30-odd meters. And he had just driven straight over Jamie. You just didn't see him. Anyway, that sort of put a real damper on the visit, I must say. We waited through that afternoon. hoping that we would see our Aussie counterparts that weren't interested in what we were trying to do, and to try and get a meeting with the GM, who we had not met yet. Anyway, at 5 o'clock, nothing had happened, so Oscar and I packed up and we went down to where we were staying. At about 7 o'clock that evening, the manager came. The lady was running the little hotel we were staying in. She said that there'd been a call from the general manager, and he wanted Oscar and I to go back up to the mine because the police were there. And the police were investigating, and because we had been the last, Oscar and I, the last people to have seen Jamie in the office, they wanted to speak to us about it. So up we went, and we spoke with them, and we met. Then they disappeared, and we met the GM, who apologized profusely for not having met us earlier. And we spent some time with him and then came back down. When I got back down, pretty morose, as you can imagine, sort of reliving the whole thing with the policeman and the GM. And the manager, the lady, came to me and said, you're coming with me now. I said, where are we going? No, you're going to a little club in the village, which we did. And I found a drink, which I'm sure you guys have all heard of, Overberg rum. I'm not sure how many bottles I drank, but I got home at about 5, back to my cabin at about 5 in the morning. We're due to leave at 6. Anyway, I don't know what the time was, about 5:30, rattling on my door, and Oscar's shouting at me, are you coming? Are you coming? You know, I jumped up, sort of washed my face and put my shoes on, took my boots off, put my shoes on, got in the vehicle, and then we went down to the harbour because we had to, you can only get into this place with a seaplane. So now I'm sitting in the ocean, having drunk at least 1 bottle of Overberg and feeling, as you can imagine how I was feeling, very quickly started to develop a sweaty upper lip and a sweaty forehead. And then we had to taxi out into the bay and then take off and then land at the other end in, where did we go? Oh, we flew to Bali. That's right, we flew to Bali. Now, and Oscar and I, on our way over, we stayed in Bali on the way there as well. And on our way back, because that's where we were going to catch the plane back to Perth from, we were going to have a seafood extravaganza lunch. Well, when we got there, I said to Oscar, I'm going to my room. I said, I won't be having lunch with you. Came out at about 4 o'clock to catch our plane to Perth. And the flight to Perth was as bad, if not worse, as the one from the mine to Bali, because of the way they were doing this bloody design. And on the eastern side of the pit, we, having traipsed around there, we could see some structures, and we thought this could be a problem because they only had a single access ramp, 1 spiral ramp that went down to the bottom of the pit. And we spoke to them about it, and they said they weren't worried, and the geotech guy said nothing will happen to their pit. And they said, if you lose that ramp, you're in big trouble because you don't have any other access. And they were adamant that nothing would happen to their pit. Anyway, we used that pit as an example in a paper that we presented in San Francisco. And if I can just claim some bragging rights, we won the award for the best technical paper at that conference, where we predicted a failure and losing the ramp and declaration of force majeure, because we'd spoken to them about force majeure as well. They didn't want to hear the word, and in fact, many of them didn't know what force majeure meant. About 2 years after we presented that paper, what happened? They had a failure in that exact spot in the open pit, and it took out the ramp, and they had to declare force majeure. There was no production from the pit for 9 months, and all they had were low-grade stockpiles that they had to use. So it was a very serious lesson learned by them at that stage. If you guys are any mine planners amongst you and you're designing pits, please don't ever do a single access open pit. The Gamsberg failure in November last year was exactly the same. Single access ramp. They had a failure which took out 2 people, equipment, and the ramp, and the only access to the bottom of the pit was via helicopter. So the mine had to hire this chopper, and the pilots spent about I don't know, about 2 weeks, ferrying people in and out of the pit to do whatever they had to do. This is another Australian operation. This is Sunrise Dam, and everything was going swimmingly. Very good blasting, as you can see on the right-hand side of the picture where my cursor is now. Very good pre-splits, and production blasts being mined out, and then a buffer taken against and going into open space, and very good pit walls. Until they decided that, and I'm not quite sure, I can't remember why they decided they needed to steepen the pit, but there was a report of some higher grades which they went after. So they did steepen the pit, and then this happened. And you can see it's migrated up, and you can see the rocks. While you've got some really good hard rocks here, you also have some highly weathered material in this area here. And that's taken out the ramp up to there. But this thing went a lot higher, and actually went all the way up the pit, right almost to the crest, taking out this ramp, and there was another ramp at the top here. They did manage to recover, and I'm not sure if they're still mining there, but I guess they might still be mining there. These were just a few pictures of Hong Kong that I've included. We were lucky enough to go on a cruise. We left from Singapore. We went up along the Vietnamese coast. We went into Ho Chi Minh. We did the tour through the tunnels, the Ho Chi Minh tunnels, to see what the Vietnamese had got up to during what they, as a matter of interest, called the American War. It's not the Vietnam War, it was the American War. And there were some pretty horrendous things that those American Marines were exposed to at that time. We did a couple of tours around Hong Kong. And what I wanted to show you, Hong Kong is built on highly weathered granite terrain, and with some quite rugged hillsides, and you can see that's the sort of the city center of Hong Kong, and all these high-rise buildings, and there are a lot of slopes that are cut there. These are all signed and registered, these slopes, and if you're the design engineer, your name and your telephone number goes on this plaque, and if something happens, if cracking starts, your number is the first number to ring that is rung, and you have to go out and go and see what's happening. As you can see, the registration number of the engineer who designed the slope, and you will get called if it is your slope, and you'll have to go out and do something about it and hope it's not too serious. That's looking down on Hong Kong from where that plaque was. You can see in the event of a big failure, you can see the kind of devastation that would be caused by that slope rushing down on all those high-rise buildings. It would be devastating. Just 2 slides to finish. Was the Hong Kong harbour. The yacht stroke boats, if you can call them that, varied. This is a small one of them, from this kind of size to people living in the harbour like this. All their ablutions are done on their boats, which go straight into the harbour. It's not recommended as a swimming pool. That, Tenny, is the end of my presentation. If there are any questions that anyone would like to ask, please feel free, and I will do my best to answer them if I can.
Thank you very much, Peter.
This is not such a serious question, but I think it's a question that you asked me in 1981 when we attended that rock conference in Tokyo.
Yeah.
And that is, what sort of, what do you use when you've got these sort of disintegrating and slaking, when you do cuttings in them, let's say in the mud rocks? Is it necessary to, is it sort of a maintenance problem mainly, or is it, do you do, let's say, shotcrete and things like that?
A lot of the cuttings are anchored and shotcreted, anchored with mesh and shotcrete, because if you just shotcrete, the shotcrete will crack as the slopes move, and of course they will move. I mean, and nothing is going to stay still ever. So they do crack. So they are the anchors. I guess the first thing that happens is a 35 mm layer of shotcrete. Then they fix the mesh. Then the anchors go through, and those face plates fix the mesh to the wall, and then they get another 75 mils of shotcrete onto them. It's mainly a maintenance job on cracked slopes. There have, however, been a number of the slopes that have failed in the earlier days. Not so much recently, because I think they're on top of those materials now. And the big issue in those early days was the actual strengths of the weathered granites, and they were low. You know, they had friction angles of maybe 20, 22 degrees, and they had cohesions of probably maybe 5 kPa, as low as that. A slope with a 520 and a C of 5 or 10 even is going to be no more than, it's going to be less than 30 degrees. And in trying to accommodate all those people in those big high-rise buildings, they couldn't afford that. So the slopes are steeper than that, but they are supported. So there is maintenance that takes place. There has to be. Anchors, bolting, shotcretes and mesh are order of the day over there.
You know, what is the use of fiber reinforced shotcrete? Is it used in the pits at all?
Yeah, fiber reinforced shotcrete is good. The only problem with it is it does cause blockages in the shotcrete machine, because the fiber somehow, no matter how you put it in, the fiber somehow forms balls in there, and they block in the pipes. So when you get a blockage, you got to stop the whole thing. You got to clean out the pipes. You got to clean out the mix, the shotcrete fiber mix, and you got to start with a new batch. So it's a problem in applying fiber shotcrete. But once it's in, it works. And because of what I've said about the fiber forming balls, you will get areas of shotcrete that you spray on the wall that has no fiber in it. So you'll get patches that's not reinforced. It's just a straight fiber. And those areas are the ones that crack first. And in fact, we did quite a lot of testing at Cullinan, Petromine, yeah. Way back in the 80s, Hendrik Kirsten and Graham Howell did a lot of shotcrete testing there, which De Beers bought into, actually. And I think that a lot of the problem that they had in those squeezing tunnels was solved by the shotcrete work that they did there, plus anchoring, because the tunnels were squeezing. I think it was Hendrik's idea that you could stop the squeezing if you put in a row around the circumference of the tunnel of longish anchors. And I think they were, if I'm not mistaken, I think they were 15 to 20 meters long with 5 meter fixed lengths and then tension to whatever the tonnage was. I can't remember the tonnage that they were tensioned to, but it did stop them closing. And in fact, Gerard Cater is doing some work at Cullinan at the moment, and their tunnels have started closing again. And I've got a feeling that they might have decided that they don't need to put in that anchor support, which of course is expensive and takes time. So it delays the mining operations and delays your ore reporting to the plant, which no manager likes. But I'm not exactly sure which material that was in. I know, John, you probably know better than I do. There's the C-cut. Which one had the bad material? Was it the C-cut? Do you recall?
Yeah, it was the C-cut, Peter, but I mean, you know, credit to Petra, I guess it started under Jimmy and Johan, is that they rebuilt that whole mine, and the block caves that they ended up putting in, I must say, were very impressive. And, you know, Cullinan is now working well. I mean, they have from time to time had some of that sort of liquid stuff that flows,
Yeah.
but I think they've compensated it pretty well. And I'm not pointing fingers at Petra here, but, you know, your comment that you just make, I mean, so many of these accidents and problems that you've highlighted are really, you know, they should have been avoided in the first place by common sense. And in the second place, if you had geologists on these mines, and we all know that very often, you know, once the mine is going, geologists almost become redundant with their cost. And the biggest problem, Peter, is, and you alluded to it, is cutting costs.
Yeah.
You know, and as we all know, I mean, Petra have had serious, you know, revenue problems and debt problems, and you know, how do you cut costs? And you know, it's a bit of an indictment on our industry too. You know, you're using shareholder money, so you know, it's not your personal money.
Yeah.
And you know, accountability, I think, is again a point you alluded to. Where is it?
Peter, that Raja Sur that you had on screen so long, where was that mine and who did it belong to? You call it Raja Sur, but it's called Raja in Spanish.
Yeah, probably. It was
The remarkable thing that I saw differently, you know, arriving there as a geotechnical guy, is their approach to safety was quite incredible, actually, in terms of South African regulations at the time. For if there was an accident, the first person that they would basically almost lock up is the mine manager. So you know that brought home safety in a big way, and their safety stats show that. It's embedded in the system. I mean, and that's why no wonder today it's topical again, moving slightly off topic, that in the news right now is the National Union of Mine Workers accusing management as a team of people that stick together and overlook this and hide it. And this is the kind of thing which is sometimes top down. The guy wants to save his job, so he's told, listen, I've got to get call at the end of the month.
Yeah.
So if you just be careful what you're warning me about, because you know
exactly.
I'm endangering them. So that's why they've got to get high up and hit hard at the top.
That's right, Jenny. That's and often those things don't report to the GM level.
Yeah.
They hope it'll go away, but it doesn't. It does go away, but with a big bang.
Yes, the silence is indicating that the guys have found it very, very interesting. You've basically said so much that we don't have to ask you much. But thank you very, very much, Peter, for a most entertaining talk.